Okay, we have an optional question, and they want you to integrate this over here. Again, it's difficult. So the first thing I did was I looked at the derivative of the bottom, and let me go through that with them. So look at this guy's derivative, and it's going to require certainly the product rule. So let me just do that for you. I'll do this over here to verify that this is true. And what do you get there? Let's take a look. You're going to get, let's see, you're going to get x times cosine x, then you can get plus sine x. I just differentiate this part, and now when you differentiate the cosine, you get minus sine. And this turns out to be pretty simple because these two terms disappear. So you're left off with x cosine x, right? And go backwards on that and highlight it. We got this over here. So it would be ideal if I saw that in the integration, but I don't. So what I did was I inserted it. All right, so let's point what I'm inserting. I'm hoping to get like this really simple integration to do. So I inserted this on top of this over here. Now you might wonder why I'm doing that. If this is u, this would be du, right? So you differentiate, you get that. I mean, it's pretty simple, all right? Maybe I should highlight the dx in that case too. All right, so what I'm gonna do is I'm gonna erase and just talk about the equivalencies now. All right, it's a reasonably tricky problem, by the way. So what I have over here is this, the integrand is equal to this over here, all right? Now remember I said about this guy over here is, this is really like the goal I have. This is really easy to integrate, all right? So what I did was I used integration by parts, all right? So what parts did I deal with? Let's go through that. I'm gonna call this thing over here dv, and I'm gonna call this thing over here the du, I'm sorry, the u in the problem. So let me show you where that is. I have this written over here. And let me go through the du part of it, all right? So how do you do the du? You take its derivative. So cosine squared in the bottom. Let's say you bring cosine to the top, multiply it by the derivative of x, which is just going to be cosine of x. And then you're going to get what? Let's take a look. Minus the top times the derivative of the bottom, which is just simply minus sine x, or plus sine x. Let me highlight this for you, show you where it's written. It's written right over here. All right? Relatively simple. All right? Okay, the other guy, and I think it's simple too, but you know, the bottom line looked kind of complicated. So, like for example, if you're integrating this guy over here, which we'll have to do because I'm calling that dv now, that means I got to integrate this guy. We'll worry about the constant of integration when we're finished with the problem, by the way. So, you know, looking at it, and kind of just going through it, let me just write that down again for you. This is x cosine x dx, and the bottom was, you know, x sine x plus cosine x, whole thing squared. I let this thing be the u, so this thing over here is the u, and that means that this thing over here is the dv in the problem, all right? So, you know, could I integrate that? Yeah, what are you going to get? You're going to get, you know, whoops, sorry about that. You're going to get 1 over u squared du, and that would be u to the minus 2. Well, then the integration would be minus 1 over u. All right? What was the u again? This is the u, and that's how we got this over here. So minus, whoops, sorry about that, minus 1 over u. Remember, this was the u over here. So I got some pretty nice things over here. And let me just start to erase things. And we're just trying to hit goals. And so we're hitting the goals we want. And the goal we wanted, I want to point this out to you, we wrote the integral again, this over here. We rewrote this like this over here. And then we came up with this using the du, the dv, and the v. Here comes the tough part. I got to write it down. All right? So what goes first? It's going to be the uv. All right? So let me write that down. The uv part. That's going to be x over cosine x times the v, which is minus 1, x sine x plus cosine x. All right? What does that give you? Well, let's go through it. It gives you x on top, but first of all, minus. What it gives you on bottom, cosine times, what we said, x sine x plus cosine x. All right, that's done. We got that part done. Let me get the eraser out. And I got to put down the VDU now. So we're going to do this part over here, the VDU. Well, let's write that down. So what are we going to get over there? Well, I see the minus sign, so I'm going to put down, it's just simply this over here, 1x, this is plus now, sine x plus cosine x times, well, what's the du? Well, the du is x sine x cosine x dx over cosine squared. What's nice about this? Things disappear. We left off with 1 over the cosine squared, and what's that going to be? Secant squared. So I'm seeing that right over here now. All right? Do I know the antiderivative of secant? I do, and it's the tangent. And we're basically done. All right? Why is that? We removed all the integration symbols, and we have it. We have it this over here, this over here. Okay, so I'm saying I'm done here. I'm done. Whoops, done. Keep doing that, don't I? Done. However, I always wondered, did I make a mistake somewhere? Did I forget somebody? Whatever. So, it took me time to get through it. I didn't find it easy, by the way. It took time. I arrived somewhere. But I wonder, I wonder, am I correct? I have no idea. Right? I don't want to differentiate that, guys. It's just too much work. So what I did was I used software. And I noticed when software, when I say software, computer programming, it gave me this answer. And I'm looking at this. Oops. I'm looking at this, and I'm looking at this, and I wonder to myself, are they the same thing? Are they the same? Or do they differ by some constant? I don't know. So what I'm going to do over here is I write it down. So I wrote down what the software gave me and what I got. And let's go through the process. I want to see if they're the same. That's what that question mark goes over there. I have no idea. So what I do, I took tangent, or in terms of sines and cosines. Not terribly difficult, by the way. And then I got a common denominator. And how would I do that? Well, I'm looking at this guy over here. So this guy's missing this factor. And I go through that. And it really doesn't look bad to do. I mean, what are you going to get? You can get x sine squared. Then you're going to get cosine x sine x. And then you get the minus x, common denominator. It still doesn't look the same. And then what I did was I rewrote the sine squared in terms of cosine squared. I multiplied it out. What are you going to get? X minus x cosine squared. That's not so bad. I get this, I get this. What disappears? The x disappears. What am I left off with? This business. All right? Minus cosine squared. I'm sorry, x minus x cosine squared. And this. Then what did I do? I factored out a cosine from the top and the bottom. All right? What do you get over there? On the bottom, you get this. And when you factor out a cosine from the top, you're going to get minus x cosine x plus sine x. Cosines are canceling off, at least conditionally they do. And we left off with sine x minus x cosine x over x sine x plus cosine x. They're the same thing. Same. All right? So our work led to the correct answer, all right? Does software lead to the correct answer? Yes. You may be shocked by this, though. If you do use software really, it does so quick, it's almost scary. And you might wonder how it's doing that. I'm not quite clear about how it's doing it, but whoever's doing the code on those software products certainly knows a great deal about integrations, all right? So that's about it. Thanks for paying attention.